A high-end dining room is carefully engineered to feel effortless, offering a pristine and artistic experience for the guest. Push through the swinging doors into the commercial kitchen, and that illusion vanishes. Profit margins hover in the single digits, and the physical space needed to store inventory is almost non-existent. With no room to store bulk goods, a restaurant's walk-in fridge can deplete entirely over the course of a single dinner service. Every essential ingredient requires a frantic daily replenishment cycle just to make it to the next shift. A restaurant's survival relies on an invisible external system, one capable of delivering precise inventory quantities hours before the sun even rises. Supplying those kitchens is a $370 billion restaurant supply chain controlled by a handful of corporate distributors. This visualization contrasts the financial scale of independent restaurants against Cisco, a single company generating $78.8 billion in annual sales. The core of this business model is extracting profit from moving heavy, highly perishable boxes of food. Behind the art of culinary hospitality lies a logistics machine where every cent of margin is engineered. Mega distributors consolidate procurement to become an indispensable partner to the kitchen. Looking at this supply pipeline, a restaurant can order fresh produce, premium cut meats, and non-food supplies like cleaning chemicals, all funneled through one single source. By fulfilling every category, the distributor captures the restaurant's total share of wallet. The restaurant gains convenience, but they also inherit massive switching costs. The true product being sold isn't food, it is inescapable operational dependency. Sustaining that level of dependency requires immense physical infrastructure, starting with the 3-temperature warehouse. This 3D cross-section maps an automated mega warehouse's climate zones: ambient, a refrigerated zone between 34 and 38 degrees, and a frozen area at -20 Celsius. Continuously monitoring these zones is a digital brain, tracking temperature thresholds 24 hours a day. In this environment, algorithmic technology is the only safeguard against catastrophic inventory loss. But the flawless digital precision of the software eventually meets the grueling physical reality of the warehouse floor. Night warehouse order selectors work 10 to 12-hour shifts through the dead of night, navigating these massive aisles on electric pallet jacks. These workers must constantly bend, twist, and manually lift inventory cases weighing between 10 and 100 pounds, often in sub-zero temperatures. The entire margin equation ultimately rests on the physical grit of human labor, timing the perfect drop. The final variable in this logistics model is route density. Margins on an individual case of broccoli or a sleeve of paper cups are razor thin. This map shows how profitability is actually achieved. The goal is to drop the maximum number of cases over the shortest possible driving distance, clustering stops to minimize fuel and labor costs. Massive corporate fleets execute this logistical footprint on the street level, moving from one loading dock to the next. In food distribution, geography and speed are the true currencies, transforming pennies per case into massive-scale profitability. The triad of one-stop procurement, cold chain infrastructure, and maximum route density makes industry giants nearly impossible to displace. Smaller local distributors may possess the food, but they lack the integrated technology and route density required to compete at this scale. When you sit in a dining room, the plate in front of you is the result of a highly engineered sequence. It is the final destination of a nocturnal algorithm, an unbroken chain of freezing air, and an exhausted night selector. The flawless illusion of modern dining is ultimately subsidized by the math of the margin equation.